Okay, so let's solve this question. The question states that consider the following context-free grammar G, where S, A, and B are variable. So basically, variables are non-terminals when we are considering grammars, right? A and B are terminal symbols. Okay, so this is the alphabet. Terminal symbols basically means the alphabet, right? And the alphabet is represented by this sign, and this alphabet is going to be equal to your A comma B. All the words of this language are going to be generated by A comma B only. That is the basic meaning of terminals in your grammar, right? And non-terminals are anything that are not your alphabet, right? And are used as variables or symbols which are used to define the rules of the grammar. That is all, right? S is a start variable, right? It is the start non-terminal, and the rules of G are described as, right? These are the rules of G, rules of the grammar. Now, which one of the following languages is accepted by G, right? So this over here is not really very accurate with what is actually happens in computer science, because the grammar, I mean, from a theory point of view, the grammar generates your language, and the language is accepted by a machine, right? So this sentence is not very accurate, but the whole direction of the meaning is very clear, I know, but from a completely theory of computer science, this is not very accurate. That is what they must have written. Which of the languages would be generated by the grammar G? That would be must have been accurate, right? Okay, but that does not really matter because there is no ambiguity. As long as there is no ambiguity, the gate score and gate marks are going to be allocated according to whichever correct language you pick, right? These languages are basically sets, right? Language is a set story construct because at least in our current modern understanding, set theory is the best way to represent a collection of objects and their manipulations, right? So a language henceforth is represented by as sets, right? These are sets that are used to define a language. Okay, now let's see that which of this kind of grammar, what kind of language is it generating? But first of all, that is first attack that we must approach, because if you were to take these languages and then try to assign them to your grammar, that can also work, I do understand. But obviously when you expand every single language and then from that pick elements, sometimes it may happen that those elements may fit together, right? They may fit together and you may not get to a result fast enough. So it is always advised that you first try to work with the grammar and see what kind of variables is it generating, right? We as humans can only perceive patterns, right? Patterns and possibilities, right? So we can perceive patterns. So this is basically representing the language in terms of patterns. That is what grammar does, right? So if we were to try to generate the elements of this language and we get to a pattern that a pattern is holistic, right? There is no deviation is not possible. We have considered every single deviation that was possible and no further deviations are possible. Then we can state that that language is going to be generated by this grammar, right? So can we do that? That is a question. So we have to attack it first, and then we can only say. So let's try. Okay, did not copy. Let's copy it right now over here. Right click, copy, then right click, paste image. Okay, so now what is the grammar actually generating, right? Every language, right? Every language is going to consist of words, right? A word is a particular sequence of your alphabet. Alphabet is already taken as A comma B, as also mentioned in the question and also evident from the grammar over here. There are only, because it is a normal custom to use capital letters to represent variables, so all small letters over here are the part of your alphabet, right? So the language over here is going to represent what? Well, let's see. The first rule, the first production is going to give you what? It is going to give you a pattern of either S is going to become A and then B, or it is going to become capital A B B, right? These small a's are terminals, so they cannot expand further. Likewise, these small b's are terminals, they cannot expand further. What can expand further? This A and this B, right? So whatever these expands to, we can directly associate it down over here or over here, right? Fine. So let's work with them right now. So A giving us this kind of pattern, right? So what is the smallest possible pattern? What is possible from this kind of A? right? Start with that, because construction can be done, right? But for that you must lay the first brick, right? And the first brick is nothing but the smallest possible element or smallest possible progress that you can make, right? Like that we construct big and complex things. So even while perceiving patterns, try to start with the smallest possible thing. And what is the smallest possible thing over here? A single A being present. So A is going to constitute to what? A set of one A, or it could become like this, A coming here and then this A becoming A again, AA, or it could become triple A, or quadruple A, and so on and so forth, right? In terms of your regular grammar, this can be written as A plus. Always advisable, try to convert your grammar into regular expression, right? This is your regular expression, A plus, right? This is nothing but your clean positive closure, right? This is basically a simple reminder of something that you must have studied in your coaching or whatever you have basically followed along while studying your computer science course, right? So this is basically for that basic reminder what is positive closure. So positive closure of A is what capital A over here represents. The same pattern is over here for B, right? As we are computer science students, we must always remember that the basic foundation of all of logic is that if all the circumstances are exactly going to be the same, then the only results would have to be the same, right? So what will this thing constitute? This will constitute nothing but the positive closure of B. Very good. Once we have that, once we have the value for what capital B will become or capital A will become, we can directly basically write it like that, and basically this becomes 2A and then 1B positive. Likewise, this is going to become A plus BB, right? And because S could go from in any direction, there is a complete possibility, right? So we can use the what is that called, inclusive OR, right? Inclusive OR that is used in your regular expressions, right? Inclusive OR basically means either this or this, both of them are equally possible. So S, your whole of your language can be represented in terms of regular expressions like this, right? Once you have your whole of language in this manner, you can directly take it and just regular expressions are very convenient when it comes to expressing your language. It is as close to what set theory gives, and sometimes in terms of language even better, right? So always try, if you are able to get either from a machine perspective or from a grammar perspective, try to get it into your regular grammar perspective, right? That is one of the best. Obviously regular grammar, what am I even saying, from a grammar perspective or from a machine perspective, try to get it to a regular expression, right? Obviously there are limitations to regular expressions, right? Because regular expressions are only limited to regular languages, right? This is a regular language because we can represent it in terms of regular expression, right? So once we have that, let's try to fit it together with the options, right? So what is the first option giving us? A raised to the power 2 is nothing but A concatenation with A and then concatenation with Bn, and n can vary from 1 till infinity, and that is mind you nothing but your first expression over here. Likewise over here, the second expression given over here is n is going to vary from 1 till infinity. So this is nothing but your second expression over here, right? And B square is present, which is going to become BB, right? So it is very clearly evident that the first option is going to be the correct one, because it matches the pattern that we got for the language while trying to synthesize the grammar into regular expression, right? So the first one is going to be a correct option. Very simple question actually, but obviously it requires certain amount of time spent with your with your computer theory of computation. That is all. Kind of some kind of time has to be spent, some kind of discussion must to be had, some kind of classes must be attended, and if you have done all those things, it is very simple forward question, you must be able to solve it, right? If you're not been able to do that, well, follow along this this video, or if you're not able to understand at all, go along on the web and you can just view some videos on this. NPTEL lectures are also very good, you can also follow them, whatever suits you, man. But obviously it is your preparation. NPTEL courses is going to take you an enormous amount of time, so if you are doing that, it is better to basically go for coaching. But depends upon what kind of strategy fits you, man. You have to live your life, so you have to decide, right? The second option, I'm just going to go through the options that are present over here so that you can know that the others are wrong, right? Because the patterns are different, right? So A n, B 2 n, right? A 2 n and B n, right? The regular expression corresponding, the regular expression cannot be constructed for this, because it is comparing, right? It is comparing the length of variables, right? And for that you need a push down automaton, and that would not be expressible in your regular expression format. So obviously this thing is a completely different category and is not really of this sort at all, right? So this cannot be the answer. The third one is LG is equals to AN BN, right? Number of A being present is equals to number of B being present, while the language that we actually got was expressible in your regular expression and was a regular language. This is a context free language, just like this one. So this is also not possible. The fourth one is LG is equals to, again, something along this thing, only the power has been doubled for both A and B, right? So this is also not possible. I don't know what they are actually getting at, because it is very simple forward question. Maybe somebody whose concepts are not very strong on context free grammar is going to read context free. Okay, so it must be a context free language, and then they're going to say that A is a regular, A is quite evidently a regular language, so they would basically neglect A and then go for the other options and then do some wrong reasoning. I don't know what, because this question is very easy. I know this was a 1 mark question, so it is supposed to be easy, but it is still a lot more easy than I would have normally expected, right? So with that, please express your were you able to understand what I was trying to explain, or is there some kind of positive part that I can add? I would really appreciate any positive feedback, any constructive feedback that you can give me. And with that, have a very good day, and have a very good preparation. Best of luck for that.